Okay, so here's an interesting problem that requires some creative thinking, at least with the solution I have, to solve it. So we have square ABDF, right? ABDF. We have our square, and what we're told about the square is that each side is 6. Now, P is a point, here's the point P, where PA, this segment, PB, this segment, and PC are all equal. We want to find the area of triangle APB, this triangle down here. Now, I'll tell you that the approach I'm taking kind of has us thinking about this in terms of where this square would sit on a graph, right? So we have this square right here, and let me just clear these points off. Okay, so sorry. We have this graph, and this allows us to use the distance formula to solve this. So that's my approach. And let me just say that when you're setting this up, you don't know the exact location of P. What you do need to know is that C here is the midpoint of line FD. That's an important, I think, concept here. That this point is the midpoint of the line FD. And the idea is that no matter where you draw a line from A or B, let me just show you, like, let's say these are our lines right here. Right? If they're going to meet at a point, that point is going to rest exactly halfway between F and D. You can think about that, or wherever we draw that. And it wouldn't work intuitively because it wouldn't meet elsewhere, I'm sorry, because let's say B is like this long, right? So over 2 and up 1. And A is the same length, but in order for A not to meet B exactly halfway, you have to be tilted, let's say, at a different angle. So maybe like, where would it even go? Here is the only location, maybe back here, right? Then they wouldn't even meet at all. So in order for them to meet, they have to meet at the midpoint. You can think about that logic. And that helps us a little bit with the graph because now, and that's kind of where the inspiration, I think, comes from the idea of a graph. You think about, oh, we have a midpoint here, so we know right away that FC, this segment, is equal to 3, and so is this one, which means that this point is halfway, so we know the y value. We know the x value, excuse me, that the point P is 3, right? Because that's halfway, 3, and then some y value. If you can make that observation, the idea of the graph, using a graph, isn't too far away. Now we want to find the length of segment CP, or PC, right? This segment right here. We want to find that. So we use our distance formula. And the distance formula, right, if we've forgotten, it's the Pythagorean theorem, really. It's the square root, d is like the hypotenuse, the square root of the difference of the x values, right, squared, plus the difference of the y values squared. And that's just saying, you have a right triangle between these 2 points with this line as the hypotenuse. These are the legs, and we're squaring them. D is the hypotenuse, solve for d. So right here we have, for the line CP, what do we know? Right? The line CP has 2 points. Point C, which is 3, 6, right? Where so C equals the point 3, 6, and P equals the point 3y. Now we plug this in, and what do we get? We'll see the difference of our x values. The x values are the same, so it's going to be 0, and the distance is going to be equal to 6 minus y squared, and the square root of that. So 6 minus y squared, I'll expand that. It's 6 minus y times 6 minus y. 6 times 6 is 36. 6 times negative y is negative 6y. Negative y times 6 is negative 6y. And plus y squared, right? So the square root of this whole thing, and that could be, right, the distance of CP equals the square root of 36 minus 12y plus y squared. So hang in there. We're actually getting pretty far in this problem. So now what would we do? Well, let's find the length of AP, right? This line right here. And see if it helps us solve this because it shares a common point P. So the distance of AP, so we have our distance of CP up here in orange. Now we're going for the distance of AP. I'll write it like this. That equals what? Well, the point A is 0, 0, and the point P is 3y. So it's the square root of our x difference, which is 3 minus 0, right? Or just 3 squared. And then what? Well, plus y minus 0 squared. So now let's simplify this, right? 3 minus 0 squared, that's 3 squared or 9. Y minus 0 squared is y squared, right? We're adding those two. square root, that's the distance of AP. And again, just to affirm, this is a right triangle. This is the idea. We're saying that D is this line, the hypotenuse, of this right triangle, where we find the difference in Y is this leg right here, and the difference in S is that leg right there. So essentially, it's the hypotenuse equals the square root of these two sides added. That's the reverse of the Pythagorean theorem. Clear that off. And this, I love these kind of problems because it seems like you're going nowhere, really, right? But really, if we know these two things are equal, they tell us, right, AP and PC are equal, then we can set these two equations equal to each other, and we'll watch as these things cancel out. So this equation, right, this distance equals this distance. We're given that. So now we can solve. So we have the square root of 36 minus 12y plus y squared, right, equals the square root of what? Of 9 plus y squared. So when you have square roots on both sides, just square everything. That'll undo the square root sign. And now we have 36 minus 12y plus y squared equals 9 plus y squared. And look what happens. This is the wonderful part. Things start to cancel out. And this line now is subtract y squared from both sides. Okay. These cancel out now. Get rid of the y squared. And then what? Well, I'm going to subtract 36 from both sides next, but I'll rewrite the equation first. Equals 9. So now I subtract 36 from both sides. And we're almost done. So now we have this. This is 0, negative 12y equals what? Well, this is negative, right, 27. Oops, negative 27. Okay, divide both sides by negative 12. And what's going to happen? Well, these cancel out. A negative divided by a negative is what? Well, it's a positive. And if it's 12 goes into 27 twice, with 3 remaining, or 3 out of, right, goes into it twice, sorry, with 3 out of 12 remaining, which is 1/4. So it's 2.25. What did we just do? Well, we found the y value of p. And now we're basically done with the problem. If we go back up, that means that p is a point, right? We can clear this off. Let's write the actual value in so you can see it. P is this point, 3, comma 2.25. So we found the exact height of it. And that means that this is the height right here. That's the height of our triangle ABP. And we're trying to find the area of that. So if the height is 2.25 times the base, 6, the area formula is 6 times the height, 2.25, cut in half, right? And then I'm just going to say 6 divided by 2 is 3. So it's 3 times 2.25, and now we have our area, 6.75 square inches. All right, I hope you enjoyed that. Thanks.